Find the fundamental set of solutions and the general solutions of the differential equations. Note that when we have a second order constant coefficient homogeneous differential equation like ay double prime plus by prime plus cy equals 0, then we can solve this equation by first finding the characteristic equation, which is just replace y double prime by r squared, y prime by r. Okay, so basically ar squared plus br plus c equals 0, and solve. And suppose we have two roots r1 and r2, real and distinct. Okay, they are separate and real roots, so obviously distinct. In that case, e raised to r1t is a solution and e raised to r2t is another solution. Okay, and they will be linearly independent. Okay, if we find the Wronskian of these two functions, that will be always non-zero. So they form a fundamental set of solutions, and the general solution will be C1 times the first solution plus C2 times second solution. Okay, let's do that over here. So for this we find the characteristic equation. Okay, so characteristic equation is y double prime, so 1 r squared plus 5r. There is no y term, so just 5r equals 0. Solve for r, so two terms, so we can factor r out. R plus 5 equals 0. So r equals 0 and r equals negative 5. 0 and negative 5 are two roots. So e raised to 0t is one solution. By the way, e raised to 0t is e raised to 0, which is 1. So this is 1. And e raised to negative 5t. So this forms a fundamental set of solutions for this differential equation, and the general solution is then general solution y is C1 first solution, C1 times 1 plus C2 times second solution, e raised to negative 5t. Okay. Similarly, for the second, let's find the characteristic equation, which happens to be r squared minus, there is no y term, y prime term, just y, so r squared minus 4 equals 0. Let's solve for r. So r equals plus minus 2. That means the fundamental set of solutions is e raised to 2t, e raised to negative 2t. And general solution is C1 times first solution plus C2 times second solution. Okay. Similarly, let's find the characteristic equation, which is r squared plus 3r minus 4 equals 0. Let's solve. R plus 4, r minus 1 equals 0, so negative 4 and 1. So the fundamental set of solutions is e raised to negative 4t, comma e raised to 1t. And general solution is then C1 times first solution. This can be first, okay? Doesn't, the order of the solutions doesn't matter. C1 first plus C2 second. Okay, and let's do the same thing for the last question. Characteristic equation, r squared minus 7r plus 4 equals 0. This does not factor because 4 times 1 is 4, and the factors of 4 never add to 7, so we need to use quadratic formula to find the roots. Okay, so r equals negative v, negative of negative 7, plus minus b squared, negative 7 squared, 49, minus 4ac, 4, 1, 4, 4, 16 over 2 times a2, which is 7 plus minus root 33 all over 2. By the way, this is a real number, so we have two roots. 7 plus root 33 over 2, one real, and another real is 7 minus root 33 over 2. It's like R1, R2, and these are distinct roots. So the solutions are the fundamental set of solutions: e raised to this junc t, 7 plus root 33 over 2t, and e raised to 7 minus root 33 over 2t. Okay, these two solutions, okay, this set forms a fundamental set of solutions, and the general solution is then y is c1 times the first solution plus c2 times the second solution. Okay, final.